Hello. Today we're going to talk about maximum and minimum values of feasible regions. Now, feasible regions are going to give you some constraints. Now, constraints are basically some inequality equations that you can graph. So first thing I'm going to do is I'm going to graph these three equations. Y is greater than 2. Actually, these should have been equal to, sorry about that. So y is greater than or equal to 2. That means no matter what, y has to go up 2. X can go left and right. So this whole line is the first equation. Second equation, x is greater than or equal to 1. So no matter what, over 1, up and down, anything. Okay? And lastly, x plus 2y is smaller than 9. Again, this is standard form, so you may need to go and figure out where your intercepts are. So when x is 0, I put x in, or 0 in the x spot, which means I'll have 2y is greater than or equal to 9, divide by 2, divide by 2, and you get y equals 4.5. Okay, when I put a 0 in there, in the y spot, I'll have x plus 2 times 0 smaller than or equal to 9. That makes 0. X is just simply x is smaller than or equal to 9. So 9 is our point. So when I graph these, I go 0 left and right up 1, 2, 3, 4.5. Put a point. And then forward 1, 2, 3, 4, 5, 6, 7, 8, 9. And put my other point. Then I'm going to draw a line connecting these points up there. And now I'm going to find my feasible region. Feasible region is an area of intersection. It's basically what gets shaded. So the green, y has to be greater than or equal to 2. Okay, well that's pretty easy. Everything greater than equal to 2. That's above this line. The red equation, x is greater than or equal to 1, well, it has to be greater than 1. So that's going to be this side of the line. And the blue equation, which side do I graph? I'm going to plug in 0, 0 to see if it works. And so when I do that, I'll have 0 plus 2 times 0 is smaller than 9. Does that work? Well, yes, 0 is smaller than or equal to 9. That's a true statement right there. So this point right here needs to get shaded. So that is this side of the line. Now, the feasible region is the area that gets shaded on all 3 times, all 3 accounts. And that is going to be right here. This little triangle forms a polygon. That little triangle is my feasible region. That satisfies all 3 of my constraints, my equations. Now, to talk about maximum and minimum values of the feasible regions, we need a formula. And we need a function of maximum and minimum values. So what we're going to do is they're going to give you, in your problems, they're going to give you 3 graphable equations right up here, which we graphed already. Then they're going to give you 1 equation, which no, you don't have to graph this. That doesn't get graphed. What that's going to be for is we're going to find the vertices of the feasible region. Now, vertices are the corners. So we have 3 corners, 1, 2, and 3. So our 3 corners are going to be over 1, up 1, 2, 3, 4, over 1, up 2, and over 1, 2, 3, 4, 5 up to. So those three vertices, those three corners of intersection are going to be where the minimum and maximum will be. So then what we're going to do is we're going to take this equation, this f of xy equals 2x minus 3y, and we're going to put in each of these points into that spot, into those equations. So to find f of 1, 4, what I'm going to do is place, it's going to equal 2 times x is 1 minus 3 times y is 4, and find my value. What does that equal? Well, 2 times 1 is 2 minus 12, that's going to be a negative 10. Okay? The next value, to find f of 1, 2, we're going to plug in 2 times 1 minus 3 times, and my y value is 2. 2 times 1 again is 2, minus 3 times 2 is 6. So 2 minus 6 is a minus 4. And last, f of 5, 2 goes into that same equation. So 2 times 5 minus 3 times 2 is going to be a 10 minus 6, which is a positive 4. So do you notice I'm just taking the 1 and putting it in the x spot, the y, putting it in the y spot. So here's my x, here's my y, here's my x, here's my y. And just putting it in that same formula to find the values. Now that I have these three values, negative 10, negative 4, and positive 4, now I can select which of these three is the maximum. Well, I would say the maximum is going to be this 4. It's the biggest of all three values. So what point did I have that in? My point of 5, 2 is going to be my maximum value at 4. My minimum, the smallest, would have been this minus 10. So the minus 10 comes from the point 1, 4. That's going to be my minimum value. And that value is a minus 10. So that's how you find the maximum and minimum value. First, graph the equations. Find your feasible region that's shaded. Find the vertices or the corners of those points. Place those points into your feasible region formula. And then pick which is the maximum and minimum. Remember, when you get into linear programming, they're going to give you story problems. And this is what you want to follow. Very kind of intuitive. It just becomes a lot of steps. Define your variables. What are your variables? What is your x and y? Or what other letters you want to use. Step 2, write a system of inequalities. You're going to have a few inequalities. Could be as few as 2 or 3. Could be as many as 8, 10, 12. It's unlimited. Step 3, graph the system of inequalities. Graph them and find your feasible region. Step 4, find the coordinates of the vertices, those corners of the feasible region, and list those points out. Step 5, write a function to be maximized or minimized. Find out what is going to be your maximum or minimum function. Step 6, substitute the coordinates of the vertices into that function. And then 7, select what is the biggest, what is the smallest result. That's the answer that you're looking for, the maximum and the minimum. Good luck. Go to work.